Assalamualaikum. So today we will discuss about uniform continuity. Alright, so now we look at to the formal definition of uniform continuity. So let the function f maps from domain D onto real number R. We say that f is uniform continuous on D if for every epsilon greater than 0, there exists a delta greater than 0 such that fx minus fy less than epsilon whenever x minus y less than delta and xy element of domain D. So you need to remember this definition. Okay, sebab kita akan guna untuk proof nanti. Okay, so kita convert to symbol. So we get this for every epsilon greater than 0, there exists delta greater than 0 such that for all xy element of domain D, so x minus y less than delta implies that fx minus fy less than epsilon. So step to prove sama macam sebelum-sebelum ni, which is the first step, we need to find the value of delta ataupun we need to choose delta. Okay, after that we can do formal proof. Okay, so now we look at to the definition, the illustration of the formal definition. Okay, what does it mean by uniform continuous? Okay, so for all epsilon greater than 0, so first kita draw dia punya straight line. So let's say the function f ni is a equation of a straight line. Okay, now for each epsilon greater than 0, so we need to choose epsilon, okay, any value of epsilon which is greater than 0. Okay, so there exists delta greater than 0. Okay, so now we need to choose the two value of x, y on domain D. Okay, so we choose value x, okay, on domain D, y also domain D. Okay, so x maps to the equation of the line of f, so we get fx, and then y maps to this line, we get fy. Okay, so next we need to choose epsilon. Okay, so epsilon dia punya jarak dia kena sama, okay, untuk fx and fy. So kita maps to this line, we get delta. Okay, so jarak untuk delta x, delta dalam range y kena sama. Okay, bila dia kata uniform, dia punya jarak ni, okay, epsilon kena sama dengan jarak epsilon sini. Okay, so bila we choose epsilon, okay, kita maps to this line, we get delta. So delta ni, okay, kena sama dengan delta ni, sama jarak. Okay, so logically, kalau equation of a straight line, kita akan dapat jarak yang sama. Okay, so this is uniform continuous function. Okay, example, we claim that the function f equals to 3x is uniform continuous. So fx ni equals to 3x, this is equation of a straight line. Okay, so equation of a straight line, they always uniform. Okay, so from definition, we need to let fx equals to 3x and then we let fy equals to 3y. So substitute into the formal definition. So kita nak prove, we need to find ataupun choose delta from consequent, and then kita reduce, one of the factor must be x minus y. So the other kita akan move to the right side. Okay, so first we need to do scratch work. So from consequent we get 3x minus 3y, and then factorize, take out 3. So one of the factor is x minus y. So kita dah reduce daripada sini ke sini. Okay, so 3 ni we can move to the right side. So that delta is equals to epsilon over 3. Okay, so next we can do formal proof. So given epsilon greater than 0, so we let delta equals to epsilon over 3. Sorry, so yang ni epsilon over 3 such that x minus y less than delta, which is epsilon over 3, then fx minus fy, so we get equals to epsilon as required. Okay, next example, the function of f equals to x squared is not uniform continuous on real number. So kita tengok graph into this graph. Okay, so this is the curve. Okay, so this is the curve of x square. Okay, now kita choose the two values. So let's say kita choose x1 and x2. So kita maps, kita dapat fx1, kita dapat fx2. So first we need to choose the range of untuk epsilon. So we choose the same range untuk epsilon, okay, on fx1 and fx2. So both ni kita maps to this curve of x square. So apa yang kita dapat? This is delta, this is delta. Okay, so delta untuk x1 ni dia lebih besar daripada delta untuk x2. Meaning that this is not uniform continuous sebab tak sama. Okay, jarak untuk epsilon sama tapi jarak untuk delta tak sama. Okay, so x square is not uniform continuous. Okay, next example, the function fx x square is uniformly continuous on D if D is a bounded set. Okay, so daripada tadi statement sebelum ni dia dah claim x square is not uniform continuous, tapi kita boleh jadikan dia uniform bila kita define dia punya domain. Domain dia kena bounded set. So for example, let's say domain dia from -3 to 3. Okay, so now we can prove that fx equals to x square is uniform continuous on domain D. Okay, so we let fx dia x square and then fy dia is y square, substitute into the formal definition. Okay, so now we need to find the delta. So to find delta from consequent, okay, from consequent ni, okay, so we start x square minus y square and then factorize, we get x minus y multiply x plus y. So one of the factor is x minus y. Next, we need to find the bound of x plus y. Okay, okay, where x approaches to y. Okay, so to find the bound of x plus y, so kita kena let dia punya x dengan y ni dalam bounded set of -3 and 3. So we let x between -3 and 3 and then we let y between -3 and 3. Okay, now we want to find x plus y. So x yang tengah ni, okay, which is x ni plus y. Okay, so we get this. So -3, so we get -6. And then on the right side, 3 plus 3, so we get 2 equals to 6. So absolute x plus y we take equals to 6. So substitute into this. Therefore, delta dia is epsilon over 6. So kalau untuk case uniform ni kita tak perlu letak minimum. Okay, tak perlu letak minimum 1 because kita hanya let x dengan y ni dalam bounded set. Okay, which is from -3 to 3. So we can start to do formal proof. Okay, so given epsilon greater than 0, so we let delta equals to epsilon over 6 such that x minus y less than epsilon over 6, then fx minus fy is equals to epsilon as required.